Good morning to all of you. Asutosh this side, and I am here presenting this topic robotics, which is assigned to me by my very teacher, whose name is Arup Kadia sir. Let's move on to the content of the table. Now we are here on this slide seeing the table of the contents of this presentation, which contains the introduction part, the evolution of robotics, basic components, advantage and challenges, future trends, case studies, and then conclusion. Now let's move on to the next slide, which contains the introduction part of robotics, which basically asks the question what robotics is. Now we are here. What is robotics? So it can be defined as the interdisciplinary branch of engineering and science, which mainly focuses on designing, constructing, and operating robots. Let's talk about the key features of robotics, like what are the key features that they source or which will be included in any kind of robots. One of the key feature is autonomy. Autonomy stands for like the person or the thing which can perform their own task all by itself. This is what we call autonomy. Let's move on to the next key feature of the is sensors and actuators. Robots use sensors to perceive their surrounding. Means sensors are used to take the data from this outside environment. And what is actuator? Then actuators is like a mini device which interacts with the data uh, taken by the sensors. Another key component is programmability. What is programmability? Any machinery things which runs on a pre-written kind of instructions, which is followed by all the machines. This is what a program is. Program is a pre-written lines of codes or instructions. Examples, let's talk about the examples of the robots. uh, we have already seen many kinds of robot. The device on which I am recording this whole presentation is also kind of robotics device. We and another examples of devices are like industrial robots, service robots, etc. Let's move on to the next slide of this presentation, which may include the evolution of robots. Oh yeah, we are here. We can see image where the which shows the medieval kind of robots, medieval automation, and then the evolution throughout these years. Let's talk about early mechanic robots. Then we moved on to the industrial robots. Then we are basically moving towards the modern AI driven robots. Let's move on to the next slide of this presentation, which contains the basic components that every robot or robotic device must have. First component is sensors. Oh, sensors, we already have discussed it. Sensors allows robots to perceive their environment and gather data. What actuator is? Actuator converts these electrical signals into physical movement, and they enable to robot to interact with their environment, with human and with another things. Controller, what is the purpose of controller? Controller is like the brain of the robot of or any robotic device. It processes the input data from sensors, make decision based on this data, and set commands to the actuator so that they can interact with the external environment. Power supply is basically like the source of energy to the robots, which is needed to these robots so that they can perform their task. Let's move on to the next slide, which contains another components like end effectors. End effectors, what is end effectors? So these are the kind of tools that is basically attached to any kind of robot, so that they can interact with the environment. One of the example I can say is grabbing or manipulating objects. This these things are achieved by the help of end effectors. Let's talk about the software. As we have discussed the programmability, so this is what a software is. The lines of programs that is included or inserted in robot or any kind of machines so that they can work accordingly to their instructions. Like we have included programs like algorithm for motion planning, for how can they perceive their environment, decision making, how can they learn from their environment, from other things, from their experiences, from their data, like this. Another thing is communication system. Every robot must have a kind of communication system installed in them. Purpose, so their purpose is to allowing any kind of robots to communicate with their external systems. Communication does not mean like I'm talking to you, you are talking to me. No, not only that kind of communication. Communication means interacting with any kind of external object. And the last and the most important thing, like chassis or body. Robots must have their kind of body. That's it. Now let's move on to the next slide. Oh, advantages and challenges that anyone faces in this sector. Let's talk about the advantages. So, increased efficiency, like human are limited to the energy and things, but with the help of robot, we can be more efficient. Robots can work 24 into 7 without any fatigue. But we human, we can fatigue even we work for an hour, like thing. It improves the precision and accuracy, complexity in programming. And let's talk about the challenges: high development costs, ethical concerns, precision, accuracy. Now let's move on to the next slide. Future trends. Now, currently, we are working on the robot which uses AI, artificial intelligence, so that they can become more human. Now, future trends: autonomous robots. What can be the trends in it? The development of robots that can operate independently without any human intervention is gaining momentum. Like basically, the robots now we have is not that superior, so so they work with the human intervention. They cannot work without any kind of human intervention. They are semi-autonomous, not fully autonomous. Yeah, there is a trend like a self-driving car where a car drives itself, finding their way on their own. But basically, it's not true. They are doing, but a kind of a little human intervention is still needed in them. We have heard of many stories where a self-driving car got into an accident, so they are not like very self-autonomous. They need human intervention. Collaborative robots, in short, cobots. Cobots are designed to work alongside humans, sharing the workspace task in a safe place, etc. AI and machine learning integration, like we have discussed, we do have robots, but these robots are not that smart. We still need an uh, super designed AI which work or which thinks as similar as we as us as humans. Another trend like swarming and multi-robot systems, robotics in space exploration, ethics and regulations in robots. Now let's talk. Let's discuss the case studies. One of the case studies I have like included in it is Boston Dynamics or Atlas robots, industrial robots or research. Overview: Boston Dynamics developed the Atlas robot, a highly advanced bipedal humanoid robot designed to navigate a variety of terrains and performs movement. Atlas is capable of walking, running, jumping, backflips, and even parkour, which makes it a cutting-edge example of robotics used in research and development and mobility. Impact this case study. Okay, fine. Let's discuss overview. What Boston Dynamics developed? They developed a kind of robot which can move in any kind of terrain. Any kind of terrain means they can even move on the plain surfaces, can move on the desert areas, can also move on the rocky or hilly areas. So that kind of robot. They can even make many kind of movements like they can like jump from one rock to another rock, one building to another building, can do backflips, can jump, etc. So this is the features that contained by the robot developed by the Boston Dynamics. Key takeaways: innovation in mobility or adaptability, real world application, the future humanoid robots, Let's move on to the next slide, okay, which contains the case study of Amazon Robotics Kiva system. Let's read the overview, then I'll explain you what it is all about. Amazon Robotics, formerly known as the Kiva system, choose a fleet of autonomous mobile robots to automate warehouse tasks. This okay. It's a kind of helping robot, or we can say it helps in the work of like arranging the goods alongside with the work alongside with the humans. So let's understand what it means. Like there is a warehouse, there are loads of things which can be arranged in a particular manner so that they can be found easily. So this kind of robots or Kiva system help the humans to arrange all this the things accordingly and efficiently, so that's how Kiva systems are used. And it is developed by Amazon Robotics. Key takeaways: impact of automation on warehouse operations, cost savings, role of robotics in the future of e-commerce. Now let's move on to the next slide, which concluded this whole session. Or so robotics stands for at the forefront of technological innovation. Ultimately, robotics represents a blend of imagination and engineering. Now let's end this with a beautiful quote, which is like the future is not just about machines replacing humans, but it is about machines and humans working together to create a something greater. This should be what our goal is to be. Okay, thank you. Now I'm ending this session. Thank you again.